Welcome everybody. Excited to be here. My name is Mike Freeman. I'm a developer advocate here at Observable, and I am thrilled to be joined by Matt Dzugan and Lionel Radisson to have a fun-filled hour or so talking about creating some animated art. Can I get some thumbs up in the chat just to make sure that the audio and video are coming through? There's a small delay, so we'll have to wait. Matt, I see that you can hear me. Carrots and pizza, wonderful. Sounds good. That is just great. So,
okay,
what's that?
I said perfect because I just saw hello from France, so I can have some time when I need to search my words in English. So if there are some French listener, maybe this would be easier.
Yeah, I wish I could say that I could host this in French, but not at all. So this is an exciting stream. I have used Observable a lot to do data visualization work, as I know a lot of folks have. But it is also becoming a really popular area for people to create and share different types of generative and computational art, which has become an interest and hobby of mine that is largely fueled by people like Lionel and Matt. So just to kick us off, Matt, do you want to go ahead and introduce yourself, and then we'll meet you, Lionel?
Yeah, sure. Hey, everyone. My name's Matt Dzugan. I've been using Observable, kind of similar to Mike, mostly to do kind of data visualizations, but more recently I've been getting into, as I guess I would call it, trying to post dank GIFs on Twitter. And so, yeah, I think I'm really obviously happy to be here with Lionel. He is amazing. And so I'm happy to share, some of I like to try to use, D3. I think people think of D3 as like a data viz tool, but it's actually really useful for a lot of this artwork stuff that we're going to talk about. And hopefully Lionel and I will talk about that a little bit. I'm a data scientist kind of by trade, by day, but I love doing all this artwork stuff kind of on the side.
Okay, thank you. I'm really amazed to be here, and I'm Lionel Radisson. I'm French, as you can hear, and I'm a creative coder as well as a teacher. Not teaching creative coding, but I'm a hobbyist creative coder, and I've been using Observable for a bit more than a year, and I learned a lot of different things and tried a lot of different things, but I'm not much using a lot of data, even though Observable is most oriented to data visualization at first, but you can do so much with it. It's a great tool, and I've done a lot with it. I think I shared a few months ago. I shared a notebook going through 1 year of Observable and creative coding. Maybe I can share the link in the comments. But yeah, I'm really excited to be here and talk about doing loops with Observable.
Well, we've got two incredibly talented and incredibly humble people here to move through some of these questions we have about generative art. And then, of course, we will also be diving into the coding as well. I've gone ahead and started sharing my stream. I imagine most of you are familiar with Observable, but if you're not, you can head to the URL that I just put in the chat, where we're going to be augmenting this notebook that combines code and output. We've put some things in there, and throughout the stream, we'll make some changes. And as soon as we make a set of changes, we'll go ahead and reshare those changes. So first up, just a little sampling. I went ahead and picked out some of their work that I really enjoyed. So we've got, as Matt would say, some dank GIFs, as he said. Don't want to open up that debate. Here is a first one working in 3 dimensions, have this sort of continually pleasant animation to watch right here. And then I've also selected some of Lionel's work, which is abundant. It's very hard to choose just one, but I think that this had some of the techniques we'll talk about today, both in terms of bringing in some randomness, some lovely colors, it's animated, and gives us a good starting point for talking about getting started with animation and creative coding. And here's something that I made. I'm not even going to call it my work, just a little bit of experimentation based largely off of Lionel's work, leveraging some of these looping concepts as well as some of this simplex noise that we'll talk about. So first things first, before we dive into the code, I want to think a little bit about what we're doing here. Is we're bringing together some sort of randomness, so there's something a bit out of our control, and then there's some combination of things that we're in control of through the code that we write or parameters that we select visually. And I think it's a little bit of an open conversation of what exactly this is creating, if this is art, if this is something else. So I'd love to hear both Matt and Lionel talk about how you see what you're doing fitting into this picture, or even something a bit broader.
Matt, do you want to start?
Sure, yeah, I can start. I think I guess sort of the way that I tend to think about this is like, maybe I have an idea that I think might make something cool, and I know I've seen a couple other artists on Twitter talk about. I think some people use the term seed hunting, where you may generate like 1,000 different versions of something and really only post to Twitter, just that one one random seed that caused a really cool one. I think to me that sort of illustrates the process here. Is like, I think a lot of times you get an idea and something can be cool if it works out right. And part of where I think, at least I can speak for myself a little bit, part of, as I've just tried this more, I've started learning a little bit more of the tricks. And, that's kind of, I think what a lot of this is really learning little tricks to take something from, oh boy, I have to generate 1 million of them and only one will be good. But the more experience you get, you can figure out like, oh, well, if I generate the random numbers in this way, then I only need to generate 1,000 of them and one will be good. But if I can generate the colors in this way, then I only need to generate 10 and one will be good. And I think that's kind of, at least for me, what it comes down to is figuring out what are the ways that you can sort of control some of the random behaviors to make it look the way that idea in your head.
That's awesome. And there was a comment that came through that gave this the term noise explorer, which I really like, that there's some field of parameters that we're searching through to get something that is aesthetically pleasing. Maybe I'll push just one more question, Matt. When you think about those ideas, is it just like, this would look cool, or are you maybe trying to capture something broader about motion or an emotion or an aesthetic? Are you sort of aiming for something more specific?
For me personally, I just really have, I guess, ideas of something that I think will look cool.
That's great.
Yeah, it's nothing more than that. I wish I could say, my brain is not big enough to think deeply in that way.
That's awesome. Well, Lionel, either if you want to give your own take on that or pick up on some of the threads from Matt, we'd be excited to hear your thoughts.
Yeah, sure. I didn't know the term seed hunter, but I really dig it. This is something that I'm doing. Like yesterday, I created a loop with some lozenge and noise, and I was like, okay, new one, new one, until I find the frames, the colors that I want, and it's just okay. This is really it, and yeah. So as I said, I'm not using a lot of data in my work, but this is all about taming randomness. You have to shape the randomness to fit your work, find the right ranges for a certain variable, and use the way that you can work with noise to find something that is going the way you want to. Usually I have a vague idea of what I want to do, but I love to create a lot of different things, either with SVG, either in 2D, in 3D, in GLSL, or so. When I am starting a project, I don't really know what I'm going to do, and this is the observation, the exploration that is creating the work usually.
Yeah, having experimented a bit, I think that the moment of surprise is such a satisfying experience when you're trying to create something like this. Is you have a vague idea, and then that randomness comes through. You're like, that's the one, right? That's what I was looking for.
Like the bug in your code that is creating the perfect effect that you will never have thought of, and it's wow, this is awesome. This is not what I had in mind, but I couldn't do something like that.
Yeah, I was going to say for me, most of the surprise comes in when I actually get the code to work.
Just anything on the screen is a pleasant surprise.
That's right.
Yeah.
And then you can call it art because you found it.
I earned it. Yeah.
All right. Any other thoughts on this, or even questions from the audience here in the chat about some of the process or intention behind creating some of these pieces to these two very generative artists?
I think one other thing that I'll add really quick, and I'm sure Lionel will agree, is even though you may have an idea about what you want to make, I think I guess, how do I say this? Kind of like art or anything, the feedback loop is so tight. Like you could never. Sometimes people on Twitter will post like the history of generative art, and like to me that's so different because those people had the constraint of they maybe write the program and then hours later or days later the result gets generated because the compute power is so low. I think I'm putting words in Lionel's mouth a little bit, but I know part of why he likes to use Observable so much, and like it just makes perfect sense, is like you can just iterate so quickly. Like I think a lot of times, and I talked about this on the last Observable stream I did, but like sometimes I'll put slider bars in there just to help me try different parameters. It's not necessarily meant for the user to have these little slider bars, but it just helps me try like, oh, do I want to have 3 colors or 4 colors or 5 colors or 6? I don't know. And so to just be able to like iterate, because I guess what I'm trying to say is how could me, the human, predict what's going to look as good as opposed to just trying them all instantly? And I think that's part of where it comes in, is being able to frame the program in such a way that allows you to like iterate on lots of different options. And that's kind of why I'm personally drawn to it, is because, as I mentioned, I'm like a data scientist by day. That process is actually very similar, of kind of like trying different parameters and like seeing what works well.
That's awesome. And we'll try and build in some of those throughout the stream here.
Yeah, exactly. You need to find, you have some parameters to create your work, but you have to find the right combination of values to create a good result. And this is most of the work, I think.
Yeah. Well, why don't we go ahead and start putting some different pieces together? I think I'll be taking this first and certainly easiest piece of the puzzle to introduce folks into the way that we use randomness in creating generative art. So you can generate a random number using a program like JavaScript, and you could just say, math.random. And every time you get that, you're going to get a different random number, and it's not going to be related to the previous number or the next number. I think that my first big lesson in generative art to achieve some of the smooth shapes or colors that you get is that you need to use some sort of randomness where a number is related to either a prior number, or you can sort of relate any pixel to other pixels in two-dimensional space. And I think this is sort of the hello world of working with generative art, is figuring out how to leverage what's called simplex noise. Do you two give your stamp of approval on that? Does that resonate? I see some nodding. So
yeah,
it's certainly something that you could implement yourself, but you can also bring in a library that will help generate this for you. And I think that this is something that is best explained visually, as is often the case. So rather than just show a random number here, I am going to switch over to HTML. These are our new cell modes, which is very exciting. So we don't have to wrap this all in template literal. So I could just create an SVG, a vector graphic, and say that the width of it is going to be this observable defined variable width. So here is our drawing space. And I'm just going to draw a bunch of circles along the horizontal. So if I take underscore dot range will give us the values from 0 to the width. I can iterate through those. And for each one, I can return a circle element. Probably my most commonly misspelled word is circle. So why don't we, along the horizontal, just put that value. For now, we can just, along CY, we can just put the value, say 10, and we can give these all a radius of 1. So right now, we just have a bunch of circles all adjacent to each other. What if we turn down the radius? So they're all going to have a value there, and we just see them adjacent. Maybe we can turn this up to 30. So we have a bunch of circles. Something that we could do for CY here is just say math.random times 30. And you're going to see that there isn't any relationship between any two of the points, right? As you move along the horizontal, you don't know how to guess what any of those next values are. But if we use this simplex noise function that we have, instead of just having a random number, we can say simplex noise in 2 dimensions. And we can just pass in that value d and a constant 1. We're going to have to multiply this by something like 50. Right now, it still looks quite varied. But if we zoom in here and divide d by, say, 100, we can see that each one of these values, we have these fluctuations up and down, some so much that they go off of the screen. Plus 25. And we have sort of predictable variation where we're getting this randomly smooth line that we have. Matt had mentioned that something that's really nice about Observable is that you can quickly explore parameters. So right now I just keep dividing by different numbers, and I can kind of get a sense that as that becomes a higher number, it becomes a smoother line. But we can also attach this or sort of tie this to what's called an input and use this concept of view of. So we're going to put something in this variable called smoothness using some inputs. Maybe let's go from the numbers 1 to 100. And we can configure this a little bit. I can get a label, smoothness. We can just go by ones, and we can give it a starting value, let's say 30. And now you can see that in this variable smoothness is just that number. So if instead of dividing by some arbitrary constant here, I divide by smoothness, we can see what this does. And really, it's zooming into this noise field or zooming out of the noise field, where you have sort of much noisier data. But as the increments between each one of these steps gets smaller, you can see this is the denominator here. We're getting closer and closer until we get something very, very smooth. If we made this 1,000, we would essentially just be going towards really small variations there. How's that for our hello world from fellow generative art folks?
That's good. I like it. I think the only other, one other thing I'll touch on is like, for people who want to go on a Wikipedia spree. I see there's already noise links to Wikipedia noise pages, but simplex noise is one of many types of noise that have like certain properties. Of course, essentially what Mike did initially with the pure JavaScript random number generator called math.random, that's what we tend to call white noise. There's also many other colors of noise, and they actually do have colors as names for other physical analogy reasons. But suffice it to say, you can go on a wild rabbit hole of looking at all these, and they all have different properties, like different behaviors and how they relate to one another in a local neighborhood. Like there's some certain types of blue noise that appear to obey certain rules locally, but then on the larger sort of scale, either in time or whatever dimension you're generating your random numbers in, then it will appear to be white noise. So I guess just suffice it to say, a reason why simplex noise is very popular is because of the fact that it has this certain property where you can get things that are actually correlated and not statistically independent in a near neighborhood, but still appear independent on other neighborhoods. But the world is your oyster as far as there's other ways to generate that. So I just wanted to make sure to kind of like say that too, because it's not that simplex noise is like some magic thing that you need to totally understand. There's lots of other things out there too. In fact, I'll just mention you can also multiply big numbers together, which is something that I do sometimes, and you can end up with lots of cool results that way too. So there's lots of fun things.
And Matt, I love that you also gave us an insight into how you spend your free time, just multiplying big numbers together.
That's why I'm in front of a whiteboard, is I just try to multiply big numbers.
Yeah. Awesome.
Yeah, and maybe about taming randomness. I think we went from math.random to simplex noise, but I think we have some steps between that we could explore. I did a notebook with a lot of different utilities that I'm using usually, where I have some randomness function, which are maybe we could explore a few of them, like random, which make you be able to have a random number from a minimum to a maximum, as well as rand int to have an integer, so that you can have some steps, or even something that I'm using as well is exponential randomness, so that you have certain values you are going to have some small values often, and the larger values you are going to have them with a really small probability. And then you have some PRNG, which are pseudo random number generator. And okay, I need to import from, sorry, utilities, rand int. So the rand, maybe I can just where's my cursor? Okay, command and okay. So here we could add something like random. I think something like that. Yeah. So, or maybe a bit smaller, like from 80 to 120. Okay, to have a range. And using rand int, the same, you can use a minimum and a maximum. But what we are going to do is like having from a rand int from 0 to 5, and then maybe we can add a minimum 50 plus rand int times 5 times 10, so that you have something like that. You are right now already we are taming the randomness. We are shaping it because I don't have real values. I don't have data to work with. I only have random number generators, and I need to shape them to get something. So there are things that we can do, or even, as I said, with X rand, which can go, let's say we want a number from 0 to 5 to 150 randomly. And so we are going to have a lot of 0 and less 150, but we can also add parameters. This is one thing that I love with Observable, is that you can create your own tools in Observable, import them, import yourself in another notebook. And let's say you can, by default, the power is 2, but you can use, let's say, 5 or 6 if you want really, or even more. And so everything is going to be like in the zeros and a few in the bigger values. So this is a way to tame your randomness. Yeah. And so we can just change it. Yeah.
This is awesome. And let's imagine that I didn't follow that incredibly beautiful description of how exactly exponential random number selectors works. I can just come here and say, well, if I want to know what power is doing, I can just make this slider and see, as I turn up the power, I have a lot more dots at the top, which is 0 pixels down. And as I shift that down, they're sort of more evenly distributed.
Yeah. And so when we are working, because we do want to talk about loops later. So a lot of the times, if we are using pure randomness, maybe we just want to initialize some values with randomness. But when all our frames are working with the randomness, we can generate randomness at each frame, or we are in complete chaos. So that's where noise comes handy, because we know we have a function that will generate the exact same value, which is likely random, but we know we can build on that to compute our different frame and have something that is going smoothly. And this is the same with PRNG. It is a pseudo-random number generator, which can use a seed. So actually, usually I'm doing something like that. Seed equal date now. This is a way to generate my seed. And I can unseed only in the future. But no, only in the present, actually. But this is a way to keep the instant. And from that, I can create a new, I can say PRNG equals new PRNG seed. And from that, maybe from that I can use.
And just while Lionel's typing, I'll just say, so for people who are not familiar with the term seed, You could imagine it actually in the old days, people generating random numbers, they were in books. They were large books with just tables of random digits in them. And so you can think of the seed as like, which page in the book do you want to go look at? That's kind of one way to think about what the seed is it's a number that will help you reproduce the set of random numbers that's going to come out. So like Lionel's saying, sometimes you actually want the same set of random numbers. So you just go look at seed, 16225, whatever. And then as long as you start there, you'll always get the same set to spool out after.
Oh, there is something I don't remember is how to use that. Okay. Now this is the same. Actually, you need to use a minimum, a maximum. And using a PRNG, I know that on every frame, I'm going to have the exact same randomness for each of my elements. So the only thing is, okay, if I'm running the cell again, okay, I have a PRNG, but every time I'm running the frame, I have some new values. It is only because I am not reinitializing my PRNG on each running of the cell. I will need a function that is initializing my PRNG at each frame to get the exact same position for each of my elements. But
all right.
It is, yeah.
Yeah,
okay,
well,
let's go.
Speaking of time, we all wanted to talk about working with time. And I'm not sure which one of you two wants to start off, but I certainly noticed in a lot of animations that they were sort of perfectly looped, that they went to an endpoint and then got back to the beginning and had this cyclical nature to them. So we need some sort of utility, some sort of understanding of moving through a set of frames, moving through time, where we're going from the start to the end, or maybe from the start to the midpoint and then back to the beginning. So I think both of you had some great ways of thinking about that. So whoever wants to dive in first, either with their cursor down here or with something else to add verbally, take it away.
Sure. I'll just go ahead and start and quickly note that kind of Lionel and I, we were talking beforehand, and we were talking about how both of us, in some of the recent stuff we've been doing, we think about things in terms of like frames and, having this whole sequence, like, much like a film strip that's going to be several hundred frames or whatever it is, which can get sort of annoying to count by, am I on the 200th frame? So one way to think about individual little animations is just on a scale of 0 to 1. And so there's actually sort of a common sort of, I guess you could call it a programming pattern, or like a code pattern to treat this problem as from a scale of 0 to 1, where 0 is the beginning of the animation and 1 is the end of the animation. How can I know where an object is, or some value of my animation as it progresses from 0 to 1? So like with 0.5 being halfway through the animation. This is a term that's called easing. It's not specific to us, computer art nerds. The like actual people who draw with pencils and markers, they actually also use the term easing. So it's like an actual animation term. But I think what we wanted to do is we kind of wanted to show how once you sort of take this like really simple assumption of going from 0 to 1 and transforming the number between 0 and 1 and transforming that into an animation value, even though it seems like a simplification, you could actually just build up like mountains of cool stuff on top of that one very simple concept. So I think what we were going to actually do is, so also both Lionel and I, we both use the actual D3 easing, I guess you call them functions. And so these again, I kind of mentioned, most people think of D3 as a data visualization library, but it's actually just a really good JavaScript library that has tons of cool math in it. And so I think we were going to kind of do a quick demo here of what this easing stuff is. So you can see Mike is actually copying in, just making sure that we in Observable kind of have access to this little D3 easing library. And so we were going to show how each of the, in fact, you can actually see this import is giving you an object back with like 100 little functions in it. Maybe not 100, but so we were going to demo what those functions are. I don't know if anyone else had anything they wanted to add to that.
No, I think this is one of the easiest way to actually when we're working with time is I don't want to say something that is false, but time is linear. In a loop, at least. It goes from 0 to 1 in a linear way. Okay. So yeah, having something linear is quite boring. So yeah, using easing is a way to animate things and have some curves, some adding some speed and some smoothness to the motion. So once again, this is an idea to smooth motion. No, maybe time is not linear. I don't know. Okay, stop. But I have a value. My value is going from 0 to 1, going from 0.01, 0.02, 0.03, and go on. So we just want to have something that is more dynamic, and this is why we can use easings. Maybe we could use funplot to see the difference between linear or something else.
Take it away.
Okay. Funplot. Okay. Let's use it. So I think this is something like funplot. You need a function, I think. So I don't know. I think it takes a function like x and you return a value like x. And I want some options like a domain, an x domain, which is going from 0 to 1, and a y domain, which is going from 0 to 1 as well. Is it going to work? Yay, perfect. Great. I love that. So I have a value, and okay, my motion, this is my time, my linear time. And so an element could move really linearly this way, yeah. But using some of the different easings function, we could shape it, shape something to go from, like, let's use easings that I don't know is, which one are we going to use? Let me see. Cubic.
Do bounce.
Okay, let's use bounce. Bounce. Oh no. Okay. Easings. Okay. Sorry. Thank you. Perfect. So here we have something that is going to bounce. Okay, it's going to move slowly at first and then accelerate, or gives the sense of an acceleration and then bounce a few times. But I think we have also something like cubic, which is going this way, or we can once again add something that is going really slowly at first and then going to accelerate. And yeah, this is a way we can shape motion as well.
Yeah, so I scrolled back upstairs, as my Gans would say. So I'm upstairs in the notebook now. And if you have a hard time wrapping your mind around what that easing would do, we've got that bouncing right here on each one of these cubes, sort of go to their end position, but then they pull back and they go back and they sort of get closer and then they have completed their animation. So Matt, is that actually how you made these blocks bounce?
Yep. And in fact, there's actually a few other ones in there. Like I see in the chat, people are talking about elastic in and out. So there's a couple other ones used in that animation. But I think one thing that I specifically want to talk about, at least in that animation, to help people kind of wrap their head around. So the way that as with, I guess, most things in programming or computer science or data analysis, any of this, it all comes down to sort of how you frame the problem. So in order to use this little function that turns something from 0 to 1 into that animation curve, that means you need to take the number of the current frame that you're on in your animation and put that in terms of 0, 1. Now, you're not just going to take the frame number, because the frame could be, number 200. So you also want to build some function that takes, your current frame number and translates it into this number between 0 and 1.
Mm-hmm.
And so that's kind of what I'm doing. If you actually just quickly scroll back up to that top one on that purple block thing, is for each different block that makes up this animation, I've assigned a different number, again, manually, but through lots of iteration, as we were kind of talking about at the beginning, through lots of iteration, I've assigned a different number, which says, when should you start doing the animation? And so basically what happens is it'll go frame by frame, and that easing will be at 0 for the whole time until it gets to its sort of starting frame. And then it starts gradually ticking from 0 to 1. And then it completes its animation, and then that thing stays at 1. So that's just kind of like a way to, so again, it comes down to how you frame the problem as part of, essentially, like Lionel said, sometimes the longest part, the hardest part, getting it to look right. The hardest part was figuring out, how do I translate each block to have a timeline that is this 0 to 1 timeline that sort of matches the durations in which I want them to sort of do this animation.
Awesome. Super helpful. And down here, I've just added a select menu so that we can just choose each one of these different easings, and you can sort of explore which one of these is appropriate for your work.
Yeah, maybe I could share a few helpers as well, because we're talking about timeline, and this is, I think this was the most difficult thing at start, because I need to create the composition. Oh, I am going to divide the time in different steps, and so from the same utilities helper, I also created a few helpers for time, working with time or a timeline, which are step, smooth step as well, and I think we also have linear step and linear step up down, which is from I don't know, kind info, or from I found these functions on the book of shader, and so they were in GLSL, and I ported them to JavaScript just to be able to use them, and they are super useful to work with the time, which is normalized between 0 and 1. So this is a really big. This notebook started with just a few functions, and progressively I added a lot of geometry function, plotter function, animation, randomness, working with arrays, everything that I really often use. It ends in this utilities notebook. So from that, I can use funplot, and let's say I have something that is going from 0 to 1. Let's use the same X domain. Okay, so I have my time, which is going from 0 to 1. I can use step on X and say, okay, at 0.5, before 0.5, you are going to be at 0, and after 0.5, you are going to be at 1. So I can define the moment I want something to just change. Let's say you want to invert the color at a specific time. Yeah, you can just set it like that. Then smooth step. Smooth step is going to use the same and take Okay. If for 0.2 you are going to be at 0, then progressively you are going to 0.5 with a smooth value. So this is a bit like the easing, but you don't have a lot of control around it because the smooth step is written. So then you can work a bit more with your time using linear step. So, okay, from 0.2 to 0.5, you are going from 0 to 1. So this is a way, since we now have a value that is going from 0 to 1 linearly, I can just use easing of that.
Unbelievable.
So I can say that you move from one value to another between this specific amount of time. And then the linear step up down is because when we are working with a loop, you want to get back to the point you were at the beginning. So you can just use your time, which is going from 0 to 1, and say, okay, from 0.2 to 0.5, you are going up. And then from 0.8 to 1, you are going down. Linear step up, down. So this is a way to get back to the starting position. And so right here we have some kind of a basic loop. At least with one value, we have something that is starting at a point and is going back to the first point. So yeah, this is a way, once again, to frame the time. So it's less linear this way.
Yeah, could we? Would it be quick-ish? So I do want to get to some of the more fun things, but could we take this and sort of implement it just below? Like, could we do something like actually change the color of an item across that timeline so that we can pair this visual of the time with actually seeing it in motion below?
Yeah, sure. Matt?
Oh, great.
Sure. Yeah. Let's try and do it here. I can. Let's see.
Maybe there is one thing we could talk about before diving into drawing things. It is about how to draw things, because we have a lot of different options. We could use SVG, or we could use Canvas. We could use 2D or 3D. So using libraries or pure JavaScript APIs. For me, I started with SVG, doing static generated SVGs, and then I tried to animate them. But at the end, I wanted to export. I knew I wanted to export GIF for MP4s. So because I had to rasterize my SVG at some point, I thought, okay, let's just do a canvas and use a canvas. But I don't know. I think Matt experimented as well with SVG.
Yeah. So I think I'll even share, because I think you even threw out some words there that I think even when I was sort of getting started, and even like learning D3 is kind of where I came across this stuff. I didn't know all these concepts. So the first thing to understand is really that the main difference between SVG and I shouldn't say the main difference. What makes there be a difference between SVG and Canvas is that when you're defining an SVG, you're defining what's called a vector graphic. It means essentially you're describing shapes. The code that lives behind an SVG is shapes. Just like if you've ever been in PowerPoint and you draw some circles in PowerPoint and you make a snowman in PowerPoint, that's you're defining shapes to make an image. That's what an SVG is. It's the literal file. If you look at myart.svg, the code behind there in that text file is just definitions of shapes. Unlike in Canvas, you're painting pixels. That's probably what we're all more kind of familiar with. We think of an image, we think of this big grid of pixels. This one's, pink, this one's red, this one's blue. That's what canvas is. So really, when you're coding an art or an animation or something, you kind of have to think, do I want to code by painting pixels? Now, this gets more complicated by the fact that when you're writing canvas code, there's a lot of utilities in there that say paint the pixels in this circle. So it makes it seem like you're still painting shape, but really the underlying sort of structure of the art is pixels.
Yeah, that filling the shape.
Filling the shapes. And that can be very useful because I know sometimes, Lionel, we were kind of talking about these tricks where you can, if you ever want to say, oh, I've painted some of my animation, let me go see, maybe you do a million different steps in your artwork. And then you want to go see, okay, after all those steps were done, what color did this pixel end up as? What color did that pixel end up as? It's a lot easier to do that in Canvas because you've painted the pixels and your browser can actually remember what color you did them. Whereas in SVG, there's no notion of that. You just have a bunch of shapes and it's hard to know exactly what color is anywhere in the world. So suffice it to say, I guess the rule of thumb for me is if you have a whole bunch of shapes that you're going to render, like I'm talking thousands or hundreds of thousands of shapes, it's probably better to go with Canvas because your browser is not going to be able to remember and render all those shapes individually. When it does it in Canvas, it renders them one at a time, and then it's just remembering the pixel colors. Whereas with SVG, you're actually storing the shapes itself.
Awesome summary. All that is to say, should we make an SVG that changes color?
Yeah, sure. That's the good thing about this example is it's small enough that we can kind of do it either way.
All right. Matt, do you want to draw us a circle?
Sure, I'll draw a circle. Let me see, where are we here? Okay, so I'll go in and I'm gonna do, I'll stay out of the E3 formula and stick first with let's just take this one and modify this. So we are going to do, actually, we're just gonna do one single circle. So just to demystify any of the magic here, let's just do, you can see what I'm editing, right?
Yeah,
absolutely.
Okay, great. So let's just do a very simple thing here for everyone to see. Okay, great. There's our one circle. Let's make it bigger. So this is, by the way, if anyone's never looked at the text file of an SVG, this is all it looks like. It's nothing too fancy. It's very human readable. In fact, I think that's one thing that makes it kind of nice is, speaking of debugging, you can go and if you generate an SVG, you can look at this. I can even literally look at this in the inspector, which, oh, that won't show up on the stream. Never mind.
I gotcha.
Mike can look at that in the inspector and see, yeah, exactly. I cannot stress, that's actually a very useful feature of SVG is to be able to see what the browser's actually doing. So, okay, great. So now we want to do color. So first thing we said, let's just, again, kind of demystify this. So this is all fairly simple. We just say fill, it's red. In fact, I can, of course, do hex color, or we can do this hex color. And so, yeah, okay. So now, like we said, we want to use Lionel's little function here. So, oh yeah, thanks. Nice, center it. So first thing we need to do is we need to actually make a clock that our browser is aware of, because right here, our browser is kind of our medium for doing this. In fact, let me throw this up here because that's kind of what I was talking about. Okay, great. So first thing we need to do is make a timer. And I guess one way to easily do this in Observable is to use what's called like a generator. And I saw in our other little prep notebook, Mike, you had made a simple little generator, didn't you?
Yeah. Do
you mind pasting in a little one-liner for that?
Yeah, so there's this great variable called now that is always updating in Observable. And if you want this to look more human readable, what if we just take that and mod by 1,000 or something?
Yeah. Great. Okay, yeah, actually, this is a great. No, yeah. This is good.
Is this what you want?
Well, this is perfect because we're about to explore lots of cool concepts here. So, like we talked about, in order to use Lionel's thing here, he's got. We want to be in this domain of 0 to 1. So maybe the first thing that we can do is we can take what Mike has done, and we can just simply, I'm just going to blindly divide this by 100. And what we'll get is we're going to get these actual quantizations, which is nice. Let's actually keep that there. We might enjoy what that does. So let's keep this there. So now we have this variable called time, which is, as you can see, it's clicking from 0 to 1, and then it just resets. By the way, if people are not familiar with this little percent sign, it's the modulo operator. I highly recommend kind of playing around with that. That's probably one of my most used concepts in creating animations like this. I'm sure Lionel would agree. And so let's now change the color. So we need to do, let's see, how can I get this? So I think what we want to do is, let's see, easings. Well, actually, I'm not super familiar with Lionel's thing. Let me try something. So I want to go. Yeah, great. Now let's see it.
You need, yeah. Now first you use the time, and then you use the step. So it would be something like 0.5. Before 0.5, it's going to be 0, and after 0.5, it's going to be 1.
So actually, maybe before we modify the color, because the interesting thing about color is we need to tell our program how to move from one color to another color, which is, we'll definitely get there, but let's build up to it with something a little bit more, I guess, straightforward first.
Yeah,
let's just modify the position.
Exactly. Let's just stick with position, and then we'll get into something more exciting.
Yeah, because color, like to go between red and blue, like what's halfway between red and blue? There's a really philosophical question for you, and there's no right answer is the answer. So let's take step and just let's do this and see what happens. So we should see it move. Okay, you saw it move like one little pixel. That's because steps range goes from 0 to 1. So if we do multiply the answer by 100, we should see this, and then it'll click up. Cool. So let's do not step. Let's try smooth step, or in fact, let's just do this one that Lionel put up here. Ooh, X is not defined.
You need to use time.
Time.
Oh yeah, of course. So now we should see. Sorry.
Yeah, this is
It's here. Hold on. I'm looking at the wrong. This cell is not actually going anywhere.
Yeah. Right. We're just having the number there.
Here we go. Now it should work. Let's see.
Yeah.
Yeah. Although, wait, how come we're not seeing it bounce? Oh, on my screen, it's because I don't have the bouncing one. I guess on your screen, you see it bounce, yeah?
I'm not seeing it bounce. I'm seeing it go linear.
Yeah, right.
We do this. Is
it's because it's linear. I'm sorry. Yeah, this is the linear one.
I think there is a step.
Yep, we got to go easings, ease.
This is what you want.
There you go.
Something like that.
Oh, there's our bounce.
There it is.
Yeah.
So
the easing function, which is taking the time, which is going from 0 to 1 between 0.2 and 0.5, and it's going from 1 to 0 between 0.8 and 0.1.
Yep.
Is it
actually yes. What we just did debugging that?
I can't hear you.
What we just did debugging that is actually like a really, I guess, kind of common concept of understanding you've got these numbers. It's all, I like how Lionel said, you know, taming the noise. I guess kind of what we're thinking about as we're talking about this is like, we know that our numbers are in some range between, you know, A and B or 0 and 1. And all of these different functions are just different ways to transform something from the range of 0 to 1 to A to B, or transform from the range of A to B back to 0 to 1, things like that. So that's kind of, I guess, what we just did.
Amazing. So I know that we had put on the meetup that we were going to be here for an hour, but I checked in with Matt and Lionel about being able to stay here for what we might term the encore. Now that we've gone through the,
we made a dot move.
Now that we've done these incredible artists, two extraordinary minds can make a circle move from up here to down here. Maybe we can transition for this last, 20, 30 minutes or so and really show where we can take this, right? I love that we've given a foundation and gotten granular about controlling these details. And now I want to see where you all take these skills.
Yeah, actually, we have all the basics that we need. Okay, we have some tools to paint pixels. Or right here, we are using SVG, but for me, at least, I'm using more, as I said, canvas. We have some control over time and some control over randomness. But then we can just use some tools like libraries. I'm using a lot of P5JS because it helps me to quickly prototype in 2D or in 3D. I also use a lot of 3GS or even GLSL, but there are a lot of different tools, but the basics are shaping time and randomness and being able to draw some shapes on the screen, or at least to draw some pixels. So I don't know. Do you want to start, Matt, or?
I don't know. I don't have anything necessarily in mind to kind of do next. I think we can. I don't know if you want to code something or if you wanted to just talk more or what.
Yeah, sure. Maybe I can do a little loop.
Sure.
So just so that we see how I am using. I am creating loops.
I would love to watch.
Okay.
All right.
Okay.
Let's scroll past this circle that's making me
feel the pressure, the pressure right now. Okay, so actually, I'm using a tool. I've done a tool to create loops and to export them in GIF or MP4. This is called PNB, and it is based on a template shared by Dave White, a Bees and Bones artist, a GIF artist, which is just incredible. And so I ported this is template, which is using processing in Java, and I ported it to JavaScript using GLSL to have some effects like motion blur and the likes, and using a few libraries as well, like P5JS for the drawing part, but also GIF.js to export GIF, and HME MP4 encoder to export MP4. And the idea is to have something which is really easy to use to create loops and to iterate from it. So again, okay. So here I have my tool, and from there I can just use all my function, which is taking it's taking an object. But if I am using, if I am using an empty object, okay, I have a loop with a canvas that is going from white to black and black to white in a scene way. So I can have a draw function, which is going to be background 0. Oh, I need a parameter which is S for sketch, or you can call it P5 or anyway. This is my first parameter, and it is the instance of P5.js. So I can now use the different function, and I can use fill 255 to have something white, and I want a circle in the middle of my canvas. So this is s.width divided by 2 and s.age divided by 2, and I want it to be 200 pixels. So I have a few default values like the width and the height of my canvas, but I can modify them using W for width and H for height, just by laziness. And then I can okay, so I have my loops, and I can define a few parameters as well in my sketch. So we want to have something that is moving. So I am using a second parameter, which is the time, that is going from 0 to 1. And from that, I can use, okay, go from, so we already have linear steps, so I can use that. Let's say I'm going to have my circle going to 100 plus linear step. I'm using the time, which is going from 0 to 1, so I'm going to say, okay, from 0.1 to 0.8, and I'm going to have my x value going from 100, so this is going to be 0 to 400, no, 300, sorry. So I have, yeah, I have a circle that is moving, and I can use easings. Easings that is quad in out, and I can take my time. And, okay, this is something that is moving already. So maybe we could position.
I broke it. Sorry, I'm breaking your code.
Okay. And yeah, I'm not adding semicolons anywhere. But let's have a first circle. So from that,
and so Lionel, I guess it's probably assumed in here that there's some duration, like because you're putting in time and it goes between 0 and 1. But I guess by default, the the loop is by default 2 seconds or something like this.
Oh yeah. So the time, I have a number of frames first, which is like 120, and I have also an FPS, the number of frames per second that I want to use. And usually I'm going between 20 or 30 frames per second.
Got it.
Okay, and so we have all this. So maybe we could have a second one, which is going in the other way. So we could have, where is it? Okay, this is going to be s.8 minus 100, and this is going to be s.width minus. And so, yes, okay, we do have 2 circles. Great. So because they are moving this way, we could do something like, okay, go from 1 to 5, and then we could just do the same thing, 100, but we are going to change the time, and it is going to move from 0.6 to 1. And okay, this is going to be the same thing with, so that we have something that is moving, because we want it to start at the beginning. So we need something that is going back to its original position. And yeah, maybe I'm going to get back to the same color so that it moves.
Oh.
Okay. And
No.
then, okay, we have something that goes back. Maybe the circle are a bit small, and I can use something like 150. So I need 150, and so this is going to be like 200, I think. Yeah. Right. Oh, okay. I made something wrong. What have I done? Okay, so we have this starting loop. So one of the really useful option of this tool is true.
Record.
Record, and then so this is going to have all our frames that are going to run, and once they're finished, you are going to have to wait a few seconds just to have the GIF created. And now you have your GIF, so you can open it, and here we go. We have a GIF. So maybe we can open it in a new tab. I don't know, but this is now a GIF.
Oh,
you need to drag and drop it, I think. Yeah.
There we go.
Yeah, okay. So this is really basic.
Hey, Lionel, do you mind if I want to share something else that I think is a interesting concept that's in here? I'm going to add one line to this code. I think what's cool about this loop is if you're not paying attention, I shouldn't say if you're not paying attention, but on first glance, it looks like it fully loops as a cycle, but it's actually not. They actually trade kind of places, and I think that's another really common kind of like trick to play with, is that if you want something to look like it's gone the full circle, you don't necessarily need to. You just need to make sure it ends up where a different string started off, and that's exactly what's happening here. And I think that happens in, I mean, I don't know, Lionel, to speak for yourself, but I think in a lot of people's artwork, they do that trick where you don't necessarily go to the start, you go to someone else's start place.
I think that Etienne Jacob, which is an awesome GIF artist, is calling it the replacement technique.
Okay, sure, yeah, okay.
So from that, I just wanted to share another option which is really useful. Okay, so we can record GIF. We can also add video true, and now we will have an MP4, and the export is actually even faster. And now you have an MP4 video, so you can right click on the video and write. Oh.
Sorry, I'm going in and trying to break your code here. Not trying to. I was trying to go in and add a bunch of additional circles here.
Yeah, but maybe if we are using random, we are going to have something that is really jiggly.
This is just my first.
Because the randomness is going to be on each frame.
Yeah,
like that.
Yeah.
That's one of the reasons. So there's different ways to get around that, but I touched on this earlier. That's one of the reasons why sometimes I multiply large numbers together, is because actually if you have, like, if you're in a loop and you are inside the loop and you want to make sure that each time in the loop that you have the 10th element be in the same place, you could either seed it with the index of the loop, or you can just say 10 times 957 million, and then do your modulo operator, and now you have essentially random number. So that's one use case for that, is to kind of, if you're looping for something and you want to keep track and make sure that one item does a similar random behavior, that's why I do that.
So this is why we also have access to the setup function, which is using which is taking two parameters, which is a P5JS instance as well as a global object where you can stick some values in it. So we could have something like g.offset equals dot range. So we have, I don't see, we have like 10 elements.
Store them and then look them up later.
Yes.
Yeah.
Map D and mat.random for times just mat.random, because the time is going from 0 to 1. So we could use it right here. So this is going to be something like I think I removed one bit too much. So that's we need to use the third parameter, which is the global object. So g.offset. So this is just an easy technique to share global values between the setup and the draw. But okay, and I need to use D. No, I need to use I think. Okay.
Which I think will be the same.
Yeah, and we need, because the time is going to be offsetted, we need to use modulo 1. And this is going to be the same right here, and right here. And now...
Oh, yeah, now we're getting somewhere.
Yeah, we have something. So it's kind of... but the moves is kind of weird, I think. We don't have what I got at the beginning. What?
There's
what did you do?
There's two circles.
What did I do?
No, look, there's two circle definitions. So maybe you want to get rid of.
They were going from there to there, and what?
What if we get rid of this second one?
Oh no, this one. Oh no, there is a missing times 200. I think. Yeah. Okay, this is it. I think there was a time where we changed. Okay, so this is
who invited the one white circle that's in the background?
Oh, I see him back there. Here, it's just. That's the opposite of what we want. Hold on.
And where is the second circle? Oh, right here we have only the first circle. So this is it. Okay. So maybe we don't want it to be in the loop. We can use it right here.
Yep.
And okay. And we want the second circle as well. So
and just
this one, I think.
Maybe just to make sure I'm following along, we've got, these are our X values.
Yeah. To create a circle on P5JS, you need to set the center X, then center Y, and then the diameter of your cycle. So
we'll give those appropriately.
And here we want to use the same offset. Okay. And now there is something where no, I need to. What? No, the modulo 1 should be actually around the time plus offset.
Oh yeah.
Because the time is going from 0 to 1, the offset is never going to be more than 1 because it is just mat.random. So this is what we want for the offset. Okay. And I think, okay. This is okay, so this is a really basic animation. And let's use a few options to have some fancy effects. We can use something like chromatic aberration. which is going to displace red, green, and blue layers. So let's use it with something a bit high. Maybe it's easier to see it with a white thing. Yeah. Okay. So maybe 4 is a bit too much. Okay. This is just a way to have some coloring in our layer. But another thing that I really like is a motion blur. So for this, we need to set 2 parameters, which are the shutter angle. So this needs to be a small value. This is like an optic, a lens, and you need to set the time you want it to be open to get some movement. So let's have something like 0.8. And we need also to specify a number of samples per frame. So this way, the BNB helper is going to compute intermediate frame instead of going from time 0 to time 0.1. It's going to go. It's going to divide this amount of time by a number of intermediate times and compute each frame, and then do an average of the frames. So we can use something like 8 frames. And okay, so there we are.
I continue to be blown away by how many topic areas I find myself going down a rabbit hole in when trying to understand these. Like suddenly I'm learning about photography. Suddenly I'm learning about 3-dimensional space. Suddenly I'm learning about sampling and time in videos. And it's incredible. And not only that we're exploring these things, but that you have created the API for experimenting with them.
Yeah, we can do so many things with and the tool grow along my different experiments, my different needs. And recently I added a shader pass, which is a way to add GLSL. Oh no, I lost my. Okay. Oh, there is something weird. I can do tab. If I'm using tab, I'm going to the following cell. Maybe because I have a French keyboard. I don't know. So this is the shader pass is taking a GLSL shader, and we can use some precision. Oh, where I am now. Precision, medium, peak float. What do we?
We are really getting in the weeds here.
I need a vec2, which is going to be uniform. Vec2, which is going to be the resolution. I'm going to need a uniform, which is going sampler 2D, which is the frame, which is called U texture, and then I can have void main. Okay, this is a rabbit hole. So let's have a UV, vec2 UV, which is going to be GL fry or.xy. This is the first time I'm doing live coding shader, I think.
Yeah, we have a completely resolution.
Yeah, because here this is based on C language, and we are computing the color for each pixel using the graphic pipeline. So each pixel are going to be computed in a parallelized way. I really recommend the book of shader once again. So we have our coordinates. Maybe we want because the coordinates in the GL space is upward or downward. I don't know the good word, the right word. We need to invert the uv.y. So we need to use 1 point minus uv.y. Then we can get the color x3c equal texture 2D. We want to go texture.
I'm excited because I have no idea what's going to pop out on the other side.
UV, and we want, okay, this is where we are going. Okay, we need to output a frag color, which is the color of the pixel based on its position and the texture right now. So we can do something like, okay, I have an error, I need RGB. Okay, I have one C and 1, which is alpha value, so I want 1. But what I want to do is just add an effect. If we are on the right of the screen, I want to be inverted. I want to invert the colors. So I can do something like if, or let's use the diagonal. I can use uv.x is more than uv.y. C equal x3. I don't know if I need to do that. So
yeah.
X3 minus C. So I am inverting my color.
That's what I was going to type,
okay.
But I wanted to give you the chance to do that.
Okay, thank you. And I may have an error. So the thing to do is open the console. What do I have? And I have nothing in the console. What?
Maybe first, just maybe comment out the whole shader thing, because I think the code was dancing around a little bit.
Okay.
Just to make sure that that's working first.
Some good collaborative debugging techniques.
Okay. Oh.
Is it working? Oh, okay.
Okay, well, this is working. So this is my fault. Okay. On it. And run. Okay, I have an error. Okay, I just need to reload the notebook maybe, because I don't have an answer, a response right here. Simpler to, oh, I think this is it.
Oh.
Okay.
Whoa. There's that moment of
there it is.
Shock and surprise.
You know the case when you are setting the lower case instead of the upper case, and it breaks everything. Okay, this is a beginner error.
Well, this is amazing. I want to be respectful of your time and the time of folks tuning in. I think this is an incredible place to end, in that it leaves us with a taste of where these can be carried forwards. Are there closing thoughts from either of you from the last hour and a half that we've spent together? Things you want to leave the folks joining us on the stream with?
Not for me. I'm happy to be here. I certainly don't consider myself like a professional at this by any means, but I don't think that should stop anyone. It's just fun to kind of, mess around. And I think this one is a perfect example. Like, this almost started off as like a little joke of a demo, just like a circle moving. But if you know the right kind of knobs to turn, like, I don't know, this is starting to actually turn out to be something kind of cool. So I think that just goes to show how, like, just a little bit of knowledge goes a long way on this stuff, and the creative opportunities are kind of endless. So definitely invite everyone to continue to kind of try this stuff.
Took the words out of my mouth.
And I think we covered a lot of different things, either randomness or working with time. And having tools. I think having tools is the most important thing, and building with the different tools that either you are making or the tools are already existing, because it really simplifies the things. And just like shader pass, right now we are using a single shader, but actually we can pass an array of shader to have different composition of effects. And yeah, this is create your own tools and make them do what you want to do.
Well, from an incredible tool maker, those are inspiring words. I'm not sure if we've moved this discussion any further, though I am now fairly confident about our ability to make dank GIFs, or GIFs, as Matt may say. It was just a pleasure to have you both join us today. We've got more exciting streams coming up. I'm going to be back on Sunday with Harry Stevens from the Washington Post, who did some of the first coronavirus simulations that were shared and trying to visually communicate that. And we're excited to take this platform where people can collaboratively live code for free and see what you can do with it, whether it is art or working with data or anything else. So thanks so much, everybody, for joining us. And a special thanks, of course, to our two guests today.
Thank you.
Yep, thank you, Mike.
All right, well, we'll see y'all next time. Thanks so much.
Bye.